Alright, so here we are in Unit 4 with Lesson 2. We're going to start with a warm-up by solving some equations here. Number 1, I'm going to factor out a common factor of x squared. So I have x squared times, what is this, 5x squared minus 7. Set that equal to 0. I can set each factor equal to 0 now, so I get x squared equal to 0, so obviously x would have to be equal to 0 here. And 5x squared minus 7 equal to 0. If we add 7 to both sides, we get x squared, 5x squared equal to 7. Dividing out the 5, we get x squared equals 7/5. And if you square root both sides, you end up with x equals the positive and the negative root of 7/5. Alright, so I'm just going to go ahead and leave that. We don't have any reason to change that. Alright. Number 2, solve this one for when x is between 0, when x goes from 0 all the way to 2 pi. So the first thing I see is a sine x in both parts of this, so I'm going to factor out a sine x. This is going to leave me 1 minus 2 cosine x. So I'm going to do the same thing that I did in the last problem. I'm going to take each factor and set it equal to 0. Well, sine x equal to 0. Alright, that's the first one we'll deal with. And then the second one is 1 minus 2 cosine x equal to 0. Alright, so sine x equal to 0. So basically we're saying, what angle would sine have a 0 ratio for? So sine of what angle? Well, we know that at x equals 0 degrees or 0 radians, sine of 0 is 0. At x equals pi radians, we are at 0. And because it includes 2 pi here, we have to go all the way around to 2 pi. Alright, so sine is equal to 0 at those three values. Solving for cosine here, I would subtract 1, so this is going to give me negative 2 cosine x equals negative 1. Divide out the negative 2, and that's cosine of x equals positive 1/2. So again, we're saying, what angle would cosine have a ratio for that gives 1/2? Alright, so if you need to, you can always look at a right triangle here. So if I were to do my little right triangle over here, I could do it just like this. Cosine, I'll put x down here. I know that the ratio is 1/2. That's adjacent over hypotenuse, so this would be 1 over 2. And since this is 1 and the hypotenuse is 2, this has got to be a special right triangle. So this would be root 3 over here. And so this turns out to be a 30, 60, 90 right triangle. And my 60 would be x right here, 60 degrees, alright, in order for that ratio to work. So we know that cosine of 60 is equal to 1/2, so we know that x could be 60, which is pi thirds. And then we continue around the unit circle, we go to quadrant 2, and x could be 2 pi thirds, but that's it up until 2 pi right there. Okay? Alright, number 3. X cubed equal x to the 1/3 plus 1. This is the cube root of x. Okay, so another way to look at this would be the cube root of x plus 1 equal to 0. Alright, so if I subtract 1, I have x to the 1/3 equals negative 1. I'm going to take both sides of this equation. To get rid of a 1/3 exponent, we want to raise both sides to the third power. Alright, so that includes the negative with that. So again, thinking about our exponent rules, 3 times the third is 1, so that's x. And negative 1 to the third power is negative 1, so x is equal to negative 1. Alright? Alright. Okay, so today we're going to talk about extrema on an interval. Basically, when we talk about extrema, we're talking about maximums and minimums here. Okay? So when we look at these graphs down here, extreme is basically what it says, extreme values, okay? So basically if you look at these two graphs to the right, we have absolute and we have relative extrema. So absolute mins, absolute maxes, relative mins, relative maxes. So if I'm looking at this graph, you can see that this graph is closed on this interval by these two solid points here. So this point right over here on the left side, this would be the absolute max. This is an absolute max. This point over here on the right side, this would be a relative max. Okay. because it's not the highest, so we would call that a relative max. This graph also has down here at 0, -3 an absolute min. Okay, so on that graph we have an absolute max and an absolute min. If you look at the next graph over here, the endpoints do not show closed like they do on the left side. So this point up at the top here would be a relative max. It wouldn't be the absolute because the right side keeps going. And this point down here would be the relative min. All right, this is the relative min. And these two equations are just showing what we're looking at. And you'll notice the left-hand side equation here does say it goes on the interval from -2 to 1. So it is closed in that interval, whereas the right one does not give you the interval, so you know it's not closed. So basically what we're going to talk about today is the extreme value theorem. And the extreme value theorem says if f is continuous on a closed interval, okay, closed on a continuous on a closed interval, so some interval a to b, like this one down here, -2 to 1, then f has both a min and a max on the interval. Okay, so if it's continuous on a closed interval, then it has to have a minimum and a maximum on that interval. And I think you can see that by this parabola over here on the left-hand side in the middle of the page here. This parabola has a max and it has a min on the closed interval -2 to 1. If I took off that interval, this parabola would not have an absolute max. It would have an absolute min, but it would not have an absolute max. So when we say that f has a minimum and a maximum on the interval, we're really saying an absolute min and an absolute max on that interval. Okay? So let's talk about how we do this. So in order to find those maxes and mins, all right, we need to be able to look at the function. So extrema, maxes and mins on a closed interval occur either at the endpoints or at critical numbers. Okay, so what are critical numbers? Critical numbers are where the derivative is equal to 0. Because when my derivative is equal to 0, so think about this. I'm just going to draw a real picture. Let's say that this is f prime of x. Okay, so this is f prime of x. Let's say this is my derivative right here. All right, so I know that at this value here, where f prime goes from positive to negative, my graph goes from increasing to decreasing. All right, so if this is f, this would be f of x then. So we know that if f prime is 0, I either have a max, or if I did it the other way, where this was my derivative, then f would have a min at this point right here. So that's why we talk about critical numbers. We want to know where the derivative is equal to 0. That could be a max or it could be a min. The other thing that we call critical numbers is where f is not differentiable. Okay, so if f isn't differentiable, then we, someplace where we have a sharp turn or a cusp, then we may not have, or we may have a max or a min at that point as well. Okay, so we will look at equations like that, or where our derivative is undefined. Is there a vertical tangent line there or something like that? So we're going to start off with a nice easy one here. We're going to look at a polynomial function. We're going to look at it on the interval from -1 to 2. It says find the absolute max and absolute min. Okay, so there's two things you have to check. You have to check f prime critical numbers. So critical numbers. Okay, now again, what are critical numbers? Critical numbers are f prime equal to 0, and critical numbers are f prime, or f f is not differentiable, or so when f is not differentiable, all right, so f not differentiable. Now the other thing we could say is we could say f prime is not defined, so I'll probably use that in the future. But so f prime of x equal to 0, or f is not differentiable at a point. All right, so if we look at this one, critical numbers, if you look at this function is a polynomial function, and so f prime would be defined. We could actually find the derivative here, which we will in just a minute, but f is prime is definitely possible at every value of x here. Okay, so there's no place on here where f is not differentiable. Okay, so we're going to look then at where f prime is equal to 0. So f prime of x is equal to, this is going to be 12x cubed minus 12x squared. I'm going to take the derivative and set it equal to 0. So I have, let me see, we'll factor out a 12x here. So 12x squared, excuse me, 12x squared times x minus 1. So 12x squared, set that equal to 0, and we get x equals 0. And x minus 1, we get x equals 0. Oops, excuse me, x equals 1. All right, so those two values of x are possibilities for max or mins. Okay, so these are possible max or mins. All right, and we'll check those in just a second. The other thing we need to do is we need to check the endpoints. All right, so we always check the endpoints. So this would be x equals -1, and I'm just going to actually do it down here, x equals 2. All right, so here we go. We need to check all 4 of those values to see which one gives us our max or min. All right, so starting, excuse me, starting with 0, if you plug 0 into the function, I think it's relatively easy to see that we're going to get 0 out of the function. If we try 1, f of 1 is going to equal, and again, hopefully this is relatively easy to see, but if you plug in 1, you're going to get 3 take away 4. 3 take away 4, so that's going to give me a -1. All right, and at x equals, oops, this one should have been a -1 over here. That's my endpoint, sorry about that. So f of -1 now, got to be a little more careful here. -1 to the 4th is still 1, is going to be 1, and 1 times 3 is 3. Minus, now we've got -1 cubed, which is -1 times -4, so that's going to actually make that +4, so that's going to equal 7. And then f of 2, plugging that into our function, 2 to the 4th is 16, and 16 times 3 is 48. And 2 cubed is 8, and 8 times 4 is 32. And 48 minus 32 is 16. All right, so the absolute, let me see, we're gonna write this out, you know, so as if we were, you know, writing it on our AP test. The absolute max is 16 when x equals 2. All right, the absolute min is, looks like it was -1 when x equals 1. Okay, so there you go. We have absolute max and min. All right, let's take a look at another example here. All right, so it's, again, it says find the absolute max and min. Make a little note up here, all right, at the top. So the first thing I'm going to do is I'm going to look for critical numbers. Critical numbers. What are critical numbers? They are where f prime of x is equal to 0 and f prime of x is undefined. All right, now that's the same thing as saying that f of x has a sharp turn or a cusp right there. Okay, so f, basically saying that f is not differentiable. Okay, so f prime of x equal to 0, f prime of x undefined. All right, so find the absolute max and min. Now you can see that f is continuous here. There's no values where it's not continuous. Okay, so that's the first thing we always want to check for, is we want to make sure, is f continuous, okay, on the interval. All right, so there's not anything that would be restricted here, not even 0 in the interval, because 0 minus 0 would be 0. We don't end up with any undefined values. So we know that we're good in terms of continuity, and so we're going to do f prime of x This is going to be the derivative, so this is going to be 2 minus. Now 2/3 times 3 is going to give me 2 times x, and subtracting 1 from the exponent, that's negative 1/3. Now I'm going to rewrite this for a particular reason this time. This is 2 minus 2, and the second 2 is over x to the positive 1/3. Now why did I do that? Because not only do we have to set this derivative equal to 0, but we also want to know if this derivative is undefined. And we can see based on this function here that f prime is undefined at x equals 0. I cannot use 0 in this function right here, otherwise I end up with 2 over 0. So that's a potential critical value right there, is x equals 0. Okay, so we're going to list critical here. So we're going to do x equals 0, and we'll check that in a minute. We also need to solve this. We need to set this equal to 0, so we're going to do 0 equals 2 minus 2 over x to the 1/3. I'm just going to go ahead. You could solve this a couple of different ways. There's a couple of different things you could do here, but I'm going to go ahead and just add 2 over x to the 1/3 to both sides. So I end up with 2x to the 1/3 equals positive 2. I'm going to cross multiply here, so I get 2 equals 2 times x to the 1/3. I'll go ahead and divide out the 2 on both sides, so that's 1 equals x to the 1/3. And if you raise both sides to the 3rd power again, okay, I'm actually going to show it just because it's important that you know this, but if I raise this side to the 3rd power, and I raise this side to the 3rd power, why am I using the 3rd power? Because 3 times 3rd is 1. I get x equals 1. Alright, so there's my second critical value, x equals 1. And then I also need to check my endpoints. So every time we do this, we're going to check not only critical, but we're going to check endpoints. Alright, so I'm going to have to check x equals negative 1, and I'm going to have to check x equals 3. Alright, so we have to plug each one of those in and see which one is the max and the min. So here we go. At 0, I think this is pretty obvious. Alright, f of 0 is going to equal 0 again. Alright, that one's an easy one. I might end up moving some of these guys up just to save some room here. At x equals 1, alright, so f of 1. Now again, if I plug in 1 to the function, I'm going to get 2 minus, and then I get 1 to the 2/3 power, which is still 1, and 1 times 3 is 3, so that's going to be 2 minus 3, which equals negative 1. Alright, I'm going to move these guys up too. Sorry if you already wrote these down. So these are endpoints now. And our endpoints were x equals negative 1, so I'm going to plug that in. So f of negative 1. Now again, if I plug in negative 1 for x, that's 2 times negative 1, which is negative 2. And this next one's going to be interesting, so I'm just going to pop it in. 3 times negative 1 to the 2/3 power. Alright, so I got to be careful with this. So I could do this a couple different ways, but I need to take the cube root, okay, that's the 3 underneath here. I need to take the cube root of negative 1, which is negative 1. Then I need to square that, which is positive 1. So now I end up with negative 2 minus 3 times positive 1, and that whole thing turns out to be negative 2 minus 3, which is negative 5. Alright, so we end up with negative 5 for that guy. And what do we got? In the last one, x equals 3. Okay, x equals 3. So f of 3. Now again, this one's going to be fun because I got some stuff going on here. I got 2 times 3. The first part's 6 minus 3 times 3 to the 2/3 power. Now here's the problem here. I can't take the cube root of 3. I don't know what that is. Even if I square the 3 first, if I do 3 squared, that's 9. I still can't take the cube root of 9. I have no idea what that is. So at this point, I would have to pop out a calculator, and this is going to turn out to be negative 0.24. All right, so at this point I just need to choose which of the values are absolute max. All right, absolute max and absolute min. So the absolute max is, and based on my calculations here, it looks like it's 0, is 0 when x equals 0. The absolute min is -5 when x equals -1. All right, so sometimes your maxes and mins are going to come from your endpoints, other times they're going to come from the critical points here. All right, let's take a look at the next one here. All right, so this time we have f of x equals 2 sine x minus cosine x from 0 to 2 pi, and we want to find out what the critical numbers are here. So starting with critical, we want to find out where the derivative is 0 or undefined. So starting off with the derivative, f prime of x. All right, so this is going to be the derivative of sine x is cosine x, so this is going to be 2 cosine x minus, okay, now we got to be careful here. We got a couple of things on here. We got the derivative of cosine x, which is going to be negative sine x, so that's going to change that to positive sine of 2x, okay, times the derivative of the inside material, so that's going to now be times 2. All right, so f prime of x is equal to 2 cosine x plus 2 sine 2x. All right, we'll set that equal to 0. Oh, by the way, that's not undefined anywhere, is it? There's no value of x that I can't plug into that function, so I know that f prime or f itself is differentiable because this derivative is defined for all values of x. Okay, there's no undefined values here. So to solve this, we're going to go ahead and set it equal to 0 now. 2 cosine x plus 2 sine 2x. I'm going to go ahead and divide by 2 on both sides, so that's going to be 0 equals cosine x plus sine 2x. Now, I got a sine and a cosine in here, and I can't swap one out for the other, but what I can do is I can replace sine of 2x with its trigonometric identity. All right, so we've got cosine x equals, or plus, now sine of 2x is a trig identity, is 2 sine x cosine x. All right, and I think you can see where we're headed. We're going to factor out a cosine of x here. So that's going to give me 0 equals cosine x times 1 plus 2 sine x. Set cosine x equal to 0. All right, so now we need the angles where cosine is 0, so x is going to equal pi over 2 and 3 pi over 2. All right, so at 90 and 270 degrees. We'll set 1 plus 2 sine x equal to 0. Subtract 1, you get 2 sine x equals -1. So sine x after dividing by 2 is equal to -1/2. All right, so now we need the angles where sine of that angle is equal to -1/2. So I know that at 30 degrees it's equal to positive. So I know it's going to be something with pi over 6. So I have to go all the way into quadrant 3, which is 7 pi 6, and then into quadrant 4, which is 11 pi 6. All right, so right here I've got 4 different possible values for maxes and mins, plus my 2 endpoints. Okay, so these guys are critical numbers. Critical numbers, and now we also need endpoints to go with it. All right, and then we have to plug each and every one of those in. This ought to be fun. All right, so here we go. Let's start off with endpoints here, so I don't forget those endpoints. So we need f of 0. So f of 0 is going to be 2 times sine of 0, 2 sine 0 minus cosine of 2 times 0. All right, so We know that sine of 0 is 0, so that part's gone. Cosine of 0 is 1, so this is equal to -1. All right, that wasn't so bad. We also need to do 2 pi, so f of 2 pi. Now, if you think about this, and again, just before I do this, I'm going to write it out here, but if I start at 0 and I go all the way around to 2 pi, I'm back at the same place I started. So this should turn out to be the exact same answer as the one above. 2 sine of 2 pi. Well, sine of 2 pi is 0, so that's 0, minus cosine of 2 times 2 pi, which is 4 pi. So again, we're all the way back around to where we started, basically at 0, so that's 1, and then the negative in front puts me at -1 again. So really, if I understand what I'm doing, I didn't even need to do that. So there's my endpoints. Now I need to do all my critical values. So f of pi over 2, this is going to be 2 sine pi over 2, all right, that's not so bad, minus cosine of 2 times pi over 2. All right, so let's see if we can do some of this in our head. Sine of pi over 2 is 1, and 1 times 2 is 2. And then the 2's are going to cancel over here on the cosine. That leaves me cosine of pi. Now, cosine of pi is -1, and I'm subtracting a -1, so that's actually going to give me a value of 3. Okay? F of 3 pi over 2. So here we go. We do 2 sine of 3 pi over 2 minus cosine of 2 times 3 pi over 2. And again, you're going to see some canceling here in a minute, but sine of 3 pi over 2, this time sine of 3 pi over 2 is -1 times 2, which is going to be -2. And then again, the 2's are going to cancel right here. Cosine of 3 pi is the same as cosine of pi, and so that's going to be minus a -1. And this time we're going to end up with -2 plus 1, which is -1. So we end up with another -1 here. All right, 2 left. F of 7 pi over 6. All right, so here we go. We've got 2 sine of 7 pi 6 minus cosine of 2 times 7 pi over 6. All right, so we got to be careful on this one. Actually, I'm going to do some work underneath here because we're going to have a little bit extra to do here. So sine of 7 pi over 6, we just got done solving for this a little bit ago, but sine of 7 pi over 6 is in the third quadrant, and so that's -1/2. So we have 2 times -1/2, and then we've got minus. Now, this one's going to be cosine, and because the 2 and the 6 are going to cancel out again, leaving me with 7 pi thirds. So I need to think about where I'm going here. If I'm looking at my unit circle, I know that 1 pi third is here, 2 pi thirds, 3 pi thirds is over here on the negative x-axis, 4 pi thirds, 5 pi thirds, 6 pi thirds, I'm back here. So 7 pi thirds is right here. All right, so this is 7 pi thirds. It's the same as pi thirds. So cosine of pi thirds is 1/2 positive, so I'm going to be subtracting 1/2 here. So 2 times -1/2 is -1 minus 1/2. That's going to give me -3/2. All right, one more time. F of 11 pi 6. All right, here we go. 2 times sine of 11 pi 6 minus cosine of 2 times 11 pi 6. All right, we're going to come down below here again for the last one. All right, so sine of 11 pi 6, that's again in the fourth quadrant. That's -1/2. So again, this is 2 times -1/2. 2 times -1/2. That wasn't too bad. Okay, the 2 and the 6 are going to cancel again, so that's 11 pi thirds. Now remember, we were at 7 pi thirds up over here earlier, so this would be 8 pi thirds, 9 pi thirds, 10 pi thirds, and 11 pi thirds. So we're down here. This is 11 pi thirds over in the fourth quadrant. Oops, 11 pi thirds. Now, again, in the fourth quadrant, cosine is positive, so that's also positive 1/2. So we're going to be subtracting 1/2. And did these two end up exactly the same? What did I do here? Cosine of 11 pi 6. 11 pi 6 times 2 is 11 pi thirds. That's definitely down here. Hang on, I got to check my math here. Alright, so yeah, this is minus 1/2 here. My answer key was wrong again, so good thing I was paying attention to this. So this is -1 minus 1/2, which turns out to be -3/2. Alright, so here we go again. The absolute max is, what was our highest value here? +3 when x equals pi over 2. The absolute min is -3/2. So -1.5, -3/2, whatever you want to call it, -3/2 when x equals, is that the lowest one? Yeah, all three of the others were -1. So when x equals 7 pi 6 and 11 pi 6. Alright, so there we go. Alright, let's see what we got on the next one here. Okay, so this next one we want to look at again. We're looking on the interval from -1 to 1, so not a very big interval, but the first thing we want to do is take f prime of x and find our critical numbers. You will notice that this function is differentiable, so 6x to the 5th is differentiable, 4 sine x is differentiable, which means that my derivative should be differentiable if I'm looking at this correctly, but let's take a quick look here. F prime of x is going to be 30x to the 4th, 30x to the 4th, which is differentiable, minus 4 times the derivative of sine is cosine x, and that is also differentiable. So again, when we're talking about critical numbers, we're looking for f prime equal to 0 and f prime undefined. Alright, so f prime undefined isn't going to count here. Now, if I set this guy equal to 0, I run into a problem here. 30x to the 4th minus 4 cosine of x. Alright, the problem is I can't solve this algebraically. Alright, you can't solve this algebraically. Now, why can't we do that? Well, the problem is we've got regular variables like a polynomial 30x to the 4th mixed with trigonometric functions, and that doesn't work. You can't do that. So the first thing we're going to do, in order for us to figure out where this guy is equal to 0, because we still have to check for maxes and mins, and we still need to check the endpoints. So what we're going to do is we're actually going to graph this thing on the graphing calculator, and we'll do ourselves a little bit of a sketch here just so we can see what this thing looks like, because we got to find the zeros using the graphing calculator now. So here we go. Let me see if I can get my graphing calculator going. We're going to start by graphing the derivative itself. Okay, so let's see if we can make this work here. Alright, so we're going to do y equals, and we'll go ahead and clear this guy out, and we're going to pop in the derivative. So we need 30x to the 4th, x to the 4th, and oops, forgot my x in there somewhere. Shoot. Alright, hang on. 30x exponent 4. There we go. That looks a little better. And minus 4 times cosine of x. Cosine of x, and I need to close the parentheses there. I'm just going to go back to a standard window here to take a look at this. And I need to figure out where this guy is equal to 0. Now you can see in here we've got 2 points where it's equal to 0. They're pretty close to 1. So I'm going to go ahead and zoom in a little bit. I'm just going to hit the zoom in. Number 2. I'll hit enter again. And that's going to give me a nice little picture. Now you can really see here where we're equal to 0. Okay? So I'm going to use my this is the function f prime of x. So we want to know where f prime of x is equal to 0 here. Now, just to kind of mess around here, I'm going to go back. I'm going to go down to y2. I'm actually going to graph the derivative here, and hopefully we'll see something nice here. 6x exponent 5 and minus 4 sine of x. Alright, so we're going to graph that on the same interval. I don't know if we're going to see it or not, what I'm looking for here. There we go, look at that. Okay, so notice the maximum value on sine x, the red graph here. Look at where my derivative is at that same value. So where I have a maximum on sine of x, I have a 0 value on the derivative. Where I have a minimum on sine x, I have a 0 where the derivative is. Okay, we've talked a lot about that. So where my function goes from increasing to decreasing, my derivative is going to go from positive to negative. So I want to find these guys right here. I want to find these values right here. I could also just find the max and the min on my original function too. So we're going to find the zeros. So we're going to go into the second menu. We're going to hit the trace button, and we're going to calculate number 2, a 0. Our calculator is going to ask us for a left bound. So we're going to bring our cursor over to the left side of that 0. Now you'll notice I need to be to the left of this point right here. So I know I'm to the left because my graph continues to the left. And we're going to give it a guess. And then it says go to the right side of that 0. So I go there and I give it another guess. And then I'm just going to hit enter. Now you can see the two boundaries. They are definitely covering that 0 right there. And that's what you're kind of looking for. Hit enter again. And it turns out that x is equal to negative 0.578. All right. So there's my x value, 0.578 negative. All right. So x equals negative 0.578. And just to kind of let you see, I mean, you can kind of tell that the graph is pretty symmetrical here about the y-axis. So this point over here, that's positive 0.578. All right, so positive 0.578. 0.578. So there's our critical values right there. And again, I hope it kind of makes sense to you. I'm just going to do a quick little sketch here, but if we were to actually sketch this function, we would have something that looks like this. All right, so there's f of x right there. This is f of x with a max here and a min here. Now you can already kind of see where some of these maxes and mins might be based on the sketch of that. Okay, so but we're going to check the interval anyway just to make sure here. And then my derivative graph went something like this. So it came down like this and then back around. I don't know how low it went, but it came back up and boom, did something like that. Okay. And so these 2 points here in green should share the same x values as those 2 points in red. At x equals negative 0.578, positive 0.578. All right, here we go. Let's check them out. So critical values, we have x equals, well, let's just do this. Let's do f of negative 0.578. Now, I'm going to cheat because I'm going to go back to my calculator here. And I'm going to go into the table, and we're going to do second table. Now, notice this time I'm going to delete this stuff. Come on. When I punch in negative 0.578 and hit enter, I don't want the value from y1, I want the value from y2. That's f of x. So I get 1.798 as my value. So this is equal to 1.798, all right, which again, if you look at the negative value at the top here of the red graph, that might make sense. F of 0.578, I bet we can take a guess at what that is. It's going to be negative 1.798. If you don't believe me, go back to your graphing calculator and pop that in. We also need to check our endpoints, f of negative 1 and f of positive 1. Now these we could do algebraically because we know what sine, nope, sine of 1, that's not going to work. Let's go back to our calculator. Alright, so I need negative 1 and I need positive 1. And again, we're looking at, and hey, they come out to be exactly the same. Negative 2.634 and positive 2.634. Alright, so which one was which here? Negative 2.634, 2.634, and positive 2.634. So based on the look of my graph, my max and min is not at the top and the bottom of these two. It's actually a little bit further over to the left. So the max at 2.634 when x equals 1, and min, and actually these should say absolutes because they are absolutes. The other two are actually relatives in this case. Absolute min at negative 2.634 when x equals negative 1. Alright, that wasn't so bad, was it? Alright, have fun.